Start this one. Okay, do you remember we had just started kind of talking about this stuff before break, but we hadn't really gotten into it a whole ton. It's not a hard deal. We're section 4.3, module 4, lesson 3 talks about solving linear quadratic systems. All that means is a system is we've got two different equations. One of them is linear. Okay, this is, if I graph this would just be the equation of a line. And we recognize the equation to be linear. How? I mean, let's take just a second and remind ourselves about that. How do we know that that's a linear equation? Tyler, what's one thing? One x value, one y value. Is anything being taken to a power or no, right? I mean, the y term is by itself, the x term is by itself, right? None of them are being taken to a power. The x's and the y's aren't being multiplied. The way I like to think about this is, if I wanted to, it's how I recognize an equation as linear. If I wanted to, I could write this in the form y equals mx plus b, or I could write it in standard form, ax plus by equals c. It is already in that form, isn't it? Right? But I could put it in the equation in slope-intercept form, for example, if I wanted to. So it's a line. Well, this one's clearly not. This one, if I were to FOIL that out, I'm going to get x squareds and x's, right, and a y. So I could put this one in the form if I wanted to. Y equals ax squared plus bx plus c, right? That's clearly quadratic, okay? So what are my choices here for ways that I could solve this system? I think the way that you guys chose was substitution, which is fine. One that we did in class, where we've got this one already solved for y, and so I can substitute, right? And then just simplify and solve. Okay. I want to maybe show you one other thing here. What else could we maybe do with this? Any ideas? Think about how you solved linear systems back in Algebra 1. Yep. Okay, linear combination or elimination works. Yeah, could we line these things up in such a way that we could, we could get one of the terms to cancel when we add the two equations up? We could. This top one we could just leave alone. How about? Oops. So this one we'll just leave as 3x minus y equals 7. But the bottom one, how about if we multiply the bottom one through by negative? Actually, we'll just leave it. We'll just leave it. It's fine. Yeah, we'll just leave it. And we'll maybe push the 4. How about if we just flip the x and the y and the 4? So we'll just write this as 4 plus y equals 2 times x plus 5 squared. Now, what happens when we add up those two equations? Well, we're going to get, it looks like on this side, the y's cancel, and I end up getting 3x plus 4. On the left side, what about the right side? I just get the sum of those two terms. So 2 times x plus 5 squared plus 7. Why is that so useful? Yeah, now we got one variable, right? And if we got one variable in an equation, we can solve it, right? What would the steps be to solving this? You guys are pretty good at this part. I don't know if we even have to necessarily do the whole thing, but how could we take care of this thing? What would we do maybe to solve this? Can I isolate x? Can't, can I? At least not yet, and probably not. How come? Yeah, I don't have a single x that I can point to. I've got an x term there, and I've got an x inside this quantity here, right? And so I don't have a single x, so I can't isolate it. So what might I probably have to do instead? What do you think? Spread it out. Yeah, I've got to maybe expand this and simplify first, right? So we could, for example, subtract 4 from both sides. So those go away and we get 3x equals 2 times the quantity, x plus 5 squared, what, plus 3? Now what? Yeah, expand the x plus 5 squared. Okay, and so if we did that, what's that going to become? If I multiply that out, expand that out.
X squared plus 10x.
Good, I could distribute the 2, right? Plus 50 plus 3. How about if we just make that 53? Oops. Last step? Yeah, move the 3x to the other side and look what we've got then. We've got 2x squared plus 17x plus 53 equals 0. Well, what's that? What do we call that? A quadratic equation in standard form. And what are our options for solving a quadratic excuse me quadratic equation in standard form? Yeah, we could complete the square. Not advisable because we got a 2 out front. Quadratic formula, sure. Just throw it into the quadratic formula and it's done, right? Does that make sense?
Yes.
And then I won't even take you through this one, but the other option would have been like here. I could just take this is a substitution equation, right? I've already got this one solved for y, so we put a box around it, and then I just substitute in there. One thing maybe we could do, well, we won't go through the whole problem, but to make this one more easy, to make it easier to do, what would our next step be? We'd have 3x minus 2 times the quantity, 1/4 times x minus 3 squared equals 13. So if I multiply 2 times 1/4, I get 1/2, right? But what's a little bit ugly about that? The fraction. Yeah, so what do I maybe want to do to clear that fraction? Yeah, multiply each side through by 2, right? And let's just see what that gives us. If I multiply each side by 2, I'd get 6x minus the 2 and the 1/2 would cancel, so minus the quantity x minus 3 squared, right? Do I have to distribute the 2 into there? No, absolutely not. Right, I'm multiplying 3 things together. 2 times 1/2 times that, right? And I multiply things in pairs. The 2 times the 1/2 became a 1. Okay, that was my goal. And then that's basically the same problem as before, isn't it? We just expand that out, distribute the negative, collect like terms, put it in standard form, and whatever the easiest way is from there. Right? That make sense? Okay, work.